Hello everyone and welcome to another episode on this very channel. In this very lesson, we shall be looking at how we can form second order PDEs from a given function. Formation of second order PDEs from a given function. If you haven't yet subscribed to the channel, kindly subscribe for me. So in the formation of second order PDEs, we will be following the same approach that we used when we were looking at the formation of first order PDEs. We are going to follow the same approach, but just that with the second order, we are going to take the partial derivative of this function with respect to the variables. We are going to take what the second partial derivative. So we'll be looking at the second partial derivative of the function with respect to x, the second partial derivative of the function with respect to y. We can also look at the second partial derivative of the function with respect to x and y, or the second partial derivative of the function with respect to y and then x. So this means that at the end of it all, in our PDE that we are going to form, we should either have this, or that, or we can have a combination of them in our PDEs. Very, very easy and then simple. So let's look at our first example on the board. Given that this function, we should form any three second order PDE from this function. So the function given is an exponential function, and we want to form any three second order PDE from that function. So as I said, we are going to follow the same approach like the one we used in the first order PDE formation. So we know that our function is giving us u is equal to e exponent x. So once we have this, we take the second partial derivative of this function with respect to x. So we have u x. We are first going to take the first partial derivative of the function with respect to x. Now let me ask you, how do we differentiate or take the derivative of an exponential function? How do we differentiate an exponential function? So let's take it that you have an exponential function of, let's say, e exponent x. How do we find our dy dx? So in finding our dy dx, what we do is we keep the function, we keep the exponential function, or we repeat it. Then we multiply it by the derivative of the exponent. So we have d dx of the exponent. So we have e exponent x multiplied by, when we differentiate x with respect to x, we are getting 1. So that is giving us e exponent x. So basically what this means is that to differentiate an exponential function, we keep the function and then we take the derivative of the exponent. We keep the function, or we repeat the function, then we differentiate the exponent. So we are going to apply the same concept here. This is an exponential function. We are going to repeat the function. So we have e exponent what? Xy. Then we differentiate the exponents with respect to what? X. So we are going to have del x. We are differentiating the exponent, which is xy, with respect to what? X. So it means that y becomes what? A constant. So we repeat y, and then we differentiate x with respect to x. That's going to give us 1. So we have y. Then we multiply it by x. So we can write it as ux is equal to y e exponent what? Xy. We are taking the second order partial differential equation. So we have to differentiate this one again. So we are going to have u xx. So we are going to differentiate this function with respect to x once again. So in doing that, we know that y becomes a constant. So we have our y. And in differentiating an exponential function, we are going to repeat the function. Then we differentiate the exponent with respect to what? Y. It's still going to give us y. So we have multiplied by y. So at the end, our second partial derivative from this is going to give us y times y will give us what? Y squared. Then we have u exponent xy. Very, very easy and then simple. So from this, we have our first one. We know that e exponent xy is what? Our u. The whole of this e exponent xy is what? Our u. So in place of this, we can write what? U. So we can write this as uxx is equal to y squared and then u. So from this, we can have our second order PDEs formed from that by bringing the right hand side to the left hand side. Let's continue from this side. So from here, we can see that uxx minus y squared u is equal to 0. So we have our first one. This is a second order partial differential equation because we have what the highest order is of 2, 1, 2, xx. So this is a second order. Now once we are done, we are going to take the second partial derivative of this function with respect to y. So we have our uy. We are going to differentiate this function with respect to y. It's an exponential function. We are going to follow the same step. We keep the function, so the function is e exponent xy. Then we take the derivative of the exponent with respect to what? Y. So if we are differentiating this with respect to y, x becomes what? A constant. Then we differentiate y with respect to y, that is given as 1. Then we multiply it by that, so we have x. So we can simplify with it and write it as x multiply e exponent xy. Now we are taking the second derivative. So we have our u y is equal to. So as we did with this one, x becomes a constant. So we are going to repeat it and then repeat the exponential function as well. Then we take the derivative of the inside. So we have del y, and that's still going to give us what? X. So we multiply it by what? X. So x times s will give us what? S squared multiplied by e exponent xy. So we said that e exponent xy is what? U is equal to u. So in place of this, we can write u over there. So we have uyy is equal to s squared and then u. So from this, we can form our second order PDE. From that, we can decide to bring this to the left hand side so that we get uyy minus s squared u is equal to 0. We have another second order PDE being formed. We are left with what? The last one, because we have to form only 3 or any 3. So let's call this equation 1 and then let's call this equation 2. Let's divide equation 1 by equation 2. So we have divide by 2. So equation 1, we have this. So we have u xx is equal to y squared e exponent xy. And then we have divided by equation 2, we have uyy is equal to what? S squared e exponent what? Xy. So from this, you can see that this can cancel this. So from here, we are left with what? uxx all over uyy is equal to y squared all over what? S squared. Now let's do some cross multiplication. This will multiply that we have s squared uxx is equal to what? Y squared uyy. Now let's bring this to the left hand side. You'll be left with what? S squared uxx minus y squared uyy is equal to 0. And this is also another second order PDE from that particular function. So as I said in our previous video, I said that if you are algebraically good, if your algebra is very strong, you can form as many PDEs as you form from a given function. Let's look at our next example. So let's look at this particular question. We want to form any three PDEs from this function len xy, len xy. So let's write our function. So our function, which is u, is equal to what? Len xy. So what we are going to do next is to take the second partial derivative of this function with respect to what? X. So we have ux, that's the first partial derivative of this function with respect to x. Now how do we differentiate a len function? How do we differentiate a len function? Let's say you have len x. We want to do what? Differentiate len x. So we have our dy dx is equal to, we differentiate what is inside all over what inside. So when we differentiate x with respect to x, we get 1 over what? X. So this is how we take the derivative of a len function. We differentiate what is inside all over what is inside. So what we are going to do is that we are going to differentiate what is inside with respect to x all over what is inside. So we have all over what is inside is what? Xy. Then we differentiate, so we have del x. We differentiate what is inside with respect to x. So with that, y becomes a constant. And when we differentiate x with respect to x, we get 1. So we have y all over what? Xy. So from here, you can see that this will cancel this. So we have our u x is equal to what? 1 over what? X. Now we are taking the second partial derivative. So we have u x is equal to. Now, with this, we can write it as x raised to the power negative 1. We are differentiating it with respect to x. We are going to differentiate this. This can be written as what? 1 over x. Or 1 over x can be written as x raised to the power negative 1. So in differentiating this, the power will come in front. So we have negative 1. And then we have minus 1 minus 1. And that's going to give us minus x raised to the power negative 2. And we can write this as minus 1 all over what? S squared, basic indices. So we are going to have the second partial derivative of this function with respect to s. We are going to have minus 1 all over what? S squared. Very, very easy and then simple. Now from this, we have uxx is equal to, we can write this as minus 1 all over x multiplying 1 all over x. Do you agree with me? We have minus 1 all over x squared. We can split it and write it as minus 1 all over x multiplying 1 all over x. This will give us what? That. Now we know that 1 over x is what? The first partial derivative of the function with respect to x. So it means in place of 1 over x, we can write ux. We have uxx is equal to minus 1 all over x multiplying what? Ux. Very, very easy and then simple. So we can do some cross multiplication, or we can do away with the denominator x by multiplying through by what? X. So we are going to have x uxx is equal to minus ux. Let's bring it to the left hand side. You have x uxx plus ux is equal to 0. So we have our second order partial differential equation. This is our first one. Now once we are done, then move on to the second partial derivative of this function with respect to y. So we have uy is equal to, we are going to differentiate this function. So what do? We differentiate what is inside all over inside. So the inside is what? Xy. Then we differentiate xy with respect to what? Y. We are going to get what? X. So this x will cancel this x. We are left with uy is equal to 1 all over what? Y. Then we differentiate again to get our second order y is equal to. So with this, we can also write 1 over y as y raised to the power -1. Now we are differentiating the function y exponent -1 with respect to y. So this negative will come in front. Then we have -1 -1. So at the end, we are going to get minus y raised to the power -2. So we can write this as what? 1 all over y squared. So we have minus, we have minus 1 all over what? Y squared. Now we can split this and write it as y is equal to -1 all over y multiplying what? 1 over y. Very, very interesting. Now 1 over y is the same as uy. So we can substitute uy in place of 1 over y. So we are going to get uyy is equal to -1 all over y multiplying what? Uy. Very, very, very interesting. So we can do away with the denominator by multiplying through by what? Y. So this is going to give us y uyy is equal to minus uy. Let's bring all of this to the left hand side of the equation. So we are going to get y uyy plus uy is equal to 0. We have another second order partial differential equation. Very, very easy. And then what's simple? So let's look at our last PDE. Now we are going to take it from these two equations. Let's call this equation 1 and then let's call this equation 2. We are going to form our second order PDE from these two equations. So we have, let's divide equation 1 by what? 2. So this is equation 1. So we have uxx is equal to -1 all over x squared. We are dividing it by equation 2, which is this. So we have uyy is equal to what? -1 all over x squared. So from this, we can write it as uxx all over uyy is equal to y squared all over what? X squared. Now we can write this as -1 over x squared times minus y squared all over what? 1. So from here, you can see that we are going to get minus y squared all over what? Minus x squared. So this will cancel this. We'll be left with y squared all over x squared. That is what I did to get this. So we are going to get x squared uxx is equal to y squared uyy. Let's bring this to the left hand side. So we are going to get x squared u x squared minus y squared uyy. So we have our last one. Very, very easy and then simple. This is not the only PDE that you can form from this one. You can form as many as you want. So far as your algebra is good. Let's look at our last example and then away bars. So let's look at this particular example. You want to form any 3 second order PDE from this function. So the function is sine xy cos xy. So first you have to write the function down plus cos xy. Now once you have this, we take the second partial derivative of the function with respect to what? X. So we are going to start with first partial derivative of the function with respect to x. So when we differentiate sine xy, we are going to get what? Cos xy. Let's differentiate the inside with respect to x, we are going to get 1. Then we have, when we differentiate cos xy, we are going to get negative y sine xy. So we have our us is equal to y cos xy minus y sine xy. Now we are taking the second partial derivative, so we differentiate again. When we differentiate cos xy, now y is treated as a constant, so we have y. Then we differentiate cos xy, we are going to get negative y sine xy. Remember, we are taking it with respect to x. Then we have minus. Now we are differentiating this with respect to x, so y becomes what? A constant. Then we differentiate sine xy with respect to x, we are going to get y cos xy. So then we have our uxx is equal to negative y squared sine xy. Then we have negative y squared cos xy. Now from here, we can say that our uxx is equal to, let's factorize negative y squared because we have negative y squared, negative y squared. We can bring it out. So we have negative y squared. Then we're going to have sine xy plus cos xy. Now within the question, we are saying that sine xy plus cos xy is equal to u. So in place of this sine xy plus cos y, we can represent it with u. So we have our uxx is equal to negative y squared u. Very, very easy. Let's continue from here. So from here, we can decide to bring all of this to the left hand side. We have uxx plus y squared u is equal to 0. So we have our second order partial differential equation. Now once we are done with this, we are also going to differentiate this function with respect to what? Y. We are going to differentiate it 2 times partially. So we have our uy is equal to, when we differentiate sine xy with respect to y, we differentiate the outside. When we differentiate sine, we get what? Cos xy. Then we differentiate the inside. So we have del y. The inside is y, xy with respect to y. We differentiate the inside with respect to y. So x will be treated as a constant. And then when we differentiate y with respect to y, we get 1. Then after that, we multiply it by that. So we have x cos xy. Then we differentiate cos xy with respect to y. When we differentiate cos, we are getting what? Negative sine xy. Then we differentiate the inside with respect to what? Y. And that is also going to give us what? X. So at the end, we have our uy is equal to x cos xy minus x sine xy. We are taking the second partial derivative, so we differentiate again. So we are going to differentiate again. We have uy is equal to, we are differentiating x cos xy with respect to y. So x here becomes a constant, so we repeat it. Then we differentiate cos xy, and that's going to give us negative sine xy. Then we differentiate the inside with respect to y, that's going to give us what? X. Then we have minus x also becomes a constant. We differentiate sine xy, we get what? Cos xy. Then we differentiate the inside with respect to y, we are going to get what? We are going to get x. Let me put it here. Okay, let me put it here, x. So we can write this as uyy is equal to negative x times x will give us x squared sine xy. This is also going to give us negative x squared cos xy. Negative x squared, negative x squared, we can factorize them out. So we are going to be left with negative x squared, then we have sine xy plus cos xy. So we said that sin xy plus cos xy is equal to u. So we are going to replace this with what? U. So we have our uyy is equal to negative x squared and then u. So we have our uyy. Bringing this one to the other side, we have plus x squared u is equal to 0. So we have another second order PDE. So let's look at the last second order PDE. We are going to take it from, let's look at this. Let's take it from this. Let's call this equation 1. And then let's call this equation 2. So we have equation 1 and then equation 2. We are going to take the second order PDE from these two equations. So what we are going to do is we are going to divide equation 1 by what? 2. So equation 1, we are having this. I'm going to write it. Then we have equation 2, we have this. We divide it by that. So from here you can see that sin xy plus cos xy will cancel themselves. You'll be left with uxx all over uyy is equal to negative y squared all over negative x squared. This is also cancel this. We are left with what? uxx all over uyy is equal to y squared over x squared. You can do some cross multiplication. This will multiply this, so we have x squared uxx is equal to what? Y squared uyy. Let's bring all of this to the left hand side. We have x squared uxx minus what? Y squared uyy. So this is another second order partial differential equation. Very, very easy. So we have 1, 2, and then 3. Now this function is a solution to this PDE that we have formed from that function. Very, very easy and then simple. This brings us to the end of today's lesson. See you tomorrow. Bye bye.